Math 107, Exam 1, Spring 2013, Problem 12. Simplify these radicals. Assume all variables are positive. So when you multiply two radicals with the same indices, you can multiply the radicands, which means whatever is under the radicals. So 3 times 15 is 45. U times u is going to be u squared, and y squared times y to the 7th is y to the 9th. And then 45 is the same as 9 times 5, so a perfect square times 5, times u squared, and then y to the 9th can be written as y to the 8th, again a perfect square times y. So the square root of 9 becomes 3, the square root of u squared becomes u, and the square root of y to the 8th becomes y to the 4th, and that has to be multiplied by the square root of 5, which well, still has to stay under the radical, and y, and nothing happened with y, so it has to be under the radical. Problem 13, rationalize the denominator. So you have to multiply top and bottom by the conjugate of the denominators, meaning you have to multiply top and bottom by square root of 3 minus 4, because you have square root of 3 plus 4. Now in the denominator you have difference of two squares, so that becomes square root of 3 squared minus 4 squared in the denominator. Numerator is just 2, the old 2, times root 3 minus 4. So the denominator becomes 3 because the square root of 3 squared is 3, minus 16, that's negative 13. Then you expand the numerator, so it's 2 times root 3 minus 8. Problem 14, add and simplify the radicals. These are all cube roots. So cube root of 16 is the same as cube root of 8 times 2. I want a perfect cube, a factor of a perfect cube. Then the cube root of 27 is just 3, because 3 cubed is 27, and the cube root of 2000 can be written as cube root of 2 times 1000. Again, I want this 1000 here because the cube root of 1000 is 10. So the cube root of 8 becomes 2, and then you have still that 2 under the cube root, so the cube root of 16 becomes 2 times the cube root of 2. And then cube root of 1000 is 10, so you multiply 3 and 10 becomes 30. And then you still have the cube root of 2. So now let's take a look at this expression. I have 2 cube root of 2 minus 30 times cube root of 2. You can actually subtract these radicals because they have exactly the same radical part, meaning this index is the same and the radicand is the same in both of them. So you have 2 minus 30 is negative 28 multiplied by the cube root of 2. Problem 15, simplify. Again, working with exponents. So now the negative exponent, negative 2/3, negative exponent means you're gonna have to take the reciprocal of whatever you have here. So that's what I wrote in my next step. X to the 6th times y to the negative 3rd, this is a negative here, over 8, so that's the reciprocal. It's still raised to the 2/3. So now I'm gonna multiply the exponent of x, 6 times 2/3, it becomes 4, so the new exponent of x is 4. The new exponent of y is negative 2 because you had negative 3, y to the negative 3, and then raised to the 2/3. So 3 and 3 cancel out, and you have negative 2. And then 8 raised to the 2/3 really means the cube root of 8 squared. So the whole thing becomes x to the 4th. Now, y to the negative 2nd has to be written in the denominator. We want positive exponents. And the cube root of 8 is 2. And then you square that 2, which becomes a 4. Problem 16. Find the circumference and area of a circle with radius 6 inches. Leave answers as multiples of pi. Do not convert pi to 3.14. So the circumference is 2 pi r. So you just replace r with 6, so you have 2 pi 6, which is 12 pi inches. The area of a circle is pi r squared, so it's going to be pi times 6 squared. Only 6 is squared, remember, not pi. So that becomes 36 pi quadratic inches. Problem 17. Find the volume of a box 1.5 inches by 5 inches by 3 inches. So these are the dimensions of the box. The volume of any box is length times width times height, so you just multiply these 3 dimensions. So 1.5 times 5 times 2. Now you can't multiply a mixed fraction, so you have to first convert it to 3/2 to an improper fraction, and you have 3/2 times 5 times 2. 2 and 2 simplify, and you get 3 times 5 is 15 cubic inches, of course. Problem 19. In the right triangle, the hypotenuse is 3 inches, one leg is 2 inches. Find the length of the missing leg. So I drew a little right triangle here. The hypotenuse is 3, one of the legs is 2, and you have to find the missing leg. So I labeled it as x. You use the Pythagorean theorem, so x squared plus 2 squared is equal to 3 squared. Remember, in Pythagorean theorem, the square of the hypotenuse is isolated, and then you have the sum of the squares of the legs. So then you have 2 squared is 4, 3 squared is 9, and you move the 4 to the other side with a negative sign, so it's going to be x squared is 9 minus 4. You subtract 9 minus 4 is 5, and then you take the square root of both sides. So you get x equals to square root of 15. You accept only positive. You should put plus or minus, but you accept only positive answer since x represents the length of the side. So the length of the side is square root of 5 inches. In problem 19, given function f of x is 1 minus x squared over x. Evaluate and simplify f of 1/2. So you just plug 1/2 in for x here and here. So f of 1/2 is equal to 1 minus 1/2 squared divided by 1/2. 1/2 squared becomes 1/4. 1 minus 1/4 is 3/4. And 3/4 divided by 1/2 multiplied by the reciprocal, so it's 3/4 times 2 over 1. Simplify, and you get 3/2. Problem 20. Which of the given equations defines y as a function of x? Remember that a function y of x is a relation between x and y for which you can get only one y for each x. So in problem A, this is definitely not a function. Y is definitely not a function of x, because for one x you can get two different y's. When you solve this equation for y, that's going to be plus or minus the square root of 3x. So if x is equal, let's say 12, y could be equal to plus or minus 2. Now c is definitely not a function. This is an equation of a circle, by the way. Again, y is squared. If you try to solve it for y, you get plus or minus the square root of 10 minus x squared. Y to the fourth minus x is equal to 0. Definitely not a function, because if you again solve it for y, you get plus or minus the square root of x, actually the fourth root of x. X is equal to 4 is a vertical line. A vertical line is definitely not a function. It doesn't pass the vertical line test. So the only one is x squared plus 7y is equal to 2. And then if you solve it for y, you're going to get 2 over 7 minus 1 over 7x squared. It's a parabola.